Okay, log rules, log 3. So we have done that one. We have done that one. We're going to do that one this video. In this video, I'm also going to show you that these aren't anything that we need. This rule here I'll show you as part of another video. It's not really used a whole lot, but you still need to know. So let's get started. We are going to do this two different ways. I guess I can just show you here. Log to base 3 of x squared. See that power? It's allowed to just come down the front. So let's write out my rules here. That's the law. That and that are exactly the same. They're equal. This 2 can come down the front, or guess what? I can take that 2 up there as well. We need to go both ways, and you'll see. But let's just have a bit of a look at that. So when I say calculate that, what I can do is I can say that I'm going to take that 5 and put it down the front, which is 5 times log 4 of 4. That is 1. 5 times 1. So I get 5. See this thing here? I can take the negative 2 and take it down. That is 1. So I can get an answer. Just looking at that, I'm thinking 4 to what power is 8? Please don't say 2, because 4 squared is 16. Can you see how I can't get an answer to that? It doesn't work. But what I can do is I can take the 2 and put it back up and go, that's the same as log 4 8 squared, which is 64. 4 to the what power is 64? 3. 4 4s are 16 and 4 16s are 64. I could not have got the answer 3 through that. It doesn't, so we've got to be able to go both ways. I can write that as log 3 to the minus a half. That can come down. That's 1. So that's negative a half. We want to go both ways. Okay. This looks like log laws 1 and 2 video. In log laws, there cannot be a coefficient in front of that log for you to apply a log law. So we have to get rid of that half by putting it to the top there. So 16 to the half. A half is the same as a square root. Root 16, 4. Let's put the 2 up there. So that's log 2 5 squared. 5 squared, 25. We are then going to go 50 times 4 divided by 25. 8, and we're going to apply the SOC rule there and get that to be 3. Equals 3, a bit messy, but anyway. Okay. Again, we cannot apply a log law with a coefficient, so that 2 has to go up there. And 5 squared is 25. Apply that log law. 25 times 4 is 100, and that's going to be 2 because 10 squared is 100. So again, you got the application of this third law in amongst applying law 1 and 2. Log x 2 to the 4, 2 to the 4, 2 2s are 4, 2 4s are 8, 2 8s are 16. Log x 16 times 3, hopefully that's 48. You can see we're introducing variables here as well. Again, we can't have that 3 there. Ooh, isn't that interesting? Let's do this 2 ways. Let's do this 2 ways. Let's put the 3 up there. Log a x cubed, log a x squared. Log a, it's going to be x cubed divided by x squared, which is log a to the x. Let's get a different colour. Let's do it a different way. Let's bring that 2 down the front. Minus 2. Can you see that that's the same as 3b minus 2b? Because they are like terms. If you've got 3 of something and you take 2 of those somethings away, you end up with just 1 of those somethings. And the answer agreed. So that was nice. We can go either way and still get the same answer. Okay. This is a trick question because many students will go 27 divided by 9 is 3. But that is not a log law. A log law is when we subtract minus log. That's when we divide. And that's not the question, is it? Okay, so we can't do that. That's what not to do. Can you see 9 and 27? What number comes to mind? Hopefully you say 3, because 3 squared is 9 and 3 cubed is 27. I can take that 3 and I can take that 2. Now, I have absolutely no idea what that number is, but it's exactly the same as that number. So they cancel, and my answer becomes just 3 on 2. That's my answer. You can see we're going to do it again. Wow, is that 7 again? That base doesn't always need to be 7, it can be anything. Let's make it 17. Can you see there's going to be 5? 5 squared is 25, and 5 to the 4, I think. So that 4 will come down, the 2 will come down. 4, 2, they cancel, so my answer to that is just going to be 2. My gosh, we've got another one. Oh, that's right. These are those 4 log rules that the textbook has as rules, but they're not. Let's look at that one. Log A of A equals 1. log to base 6 of 6. 6 to what power is 6? 1. So A and A equals 1. That's nothing more than the application of the SOC rule. You don't need to remember that. That's just foundational understanding. You just know that. Look at that one. Log A. A to what power is 1? Well, that's the 0 power, isn't it? So again, that's just common sense. It's not something you need to remember. It's the application of the SOC rule. This one. Well, 1 on A, well, isn't 1 on A to the minus 1? So A to what power is A to the minus 1? Oh, minus 1? We don't need to remember these things. Silly textbook. Just making it complicated for you poor little kids. How about log to base 7 of 7 to the power 24? Well, what does that equal? Remember? And that 24 comes down there and that's just 1. Or we're going to say 7 to what power is 7 to the 24? It's just 24. Craziness. So those are not rules. You don't need to know them. They're just an application of the SOC rule. Okay, get in there. This is harder than it looks. You need to practice like there's no tomorrow.